Hello everyone, welcome to the session from Department of Civil Engineering, SNS College of Technology. In today's video lecture series, we are going to discuss a very important topic in mechanics of materials, that is indeterminate beams and the concept of analysis. This topic forms the foundation for advanced structural analysis and it is widely used in real-life structures like bridges, buildings and industrial frames. By the end of this session, you will clearly understand about what indeterminate beams are, why they are important, how engineers analyze them. Let's get started. Before moving into today's concept, let's quickly recall what we have learned from the previous topics. In earlier classes, we have studied statically determinate beams such as simply supported beams, cantilever beams, etc. In these cases, we use three basic equilibrium equations. That is, summation of vertical forces is 0, summation of horizontal forces is 0, and summation of moments is 0. These equations were sufficient because the number of unknown reactions were equal to the number of equations. Example, if a simply supported beam has two reactions, we can solve easily using equilibrium conditions. But now think, what if the number of supports increases? What if unknowns becomes more than equations? That's why today's topics gains more importance. In today's session, we will explore four important aspects. First one, what is a statically indeterminate beam? Second is why equilibrium equations alone are not sufficient. Next is the role of deformation compatibility and the real life applications. We will also see how this concept connects theory with practical engineering. Now let's define the concept clearly. A statically indeterminate beam is a beam in which the number of unknown reactions is greater than the number of available equilibrium equations. So what happens here? We cannot solve using equilibrium equations alone. We also need additional equations. These additional equations come from compatibility of deformation. What does that mean? It means the beam must deform in a way that satisfies support conditions. Deflection and rotation must be consistent. Example, consider a beam fixed at both ends. You cannot determine reactions only using equilibrium condition. You must also consider how the beam bends. So indeterminate analysis combines statics, material behavior and deformation concepts. This makes it more realistic. Now let's understand why engineers prefer indeterminate beams. In real world structures, supports are rigid, not ideal at hinges. Multiple supports are provided for safety. Structure should not fall if one support weakens. Because of this, indeterminate beams offer several advantages. The advantages are load distribution, that is, loads are shared among multiple supports, and reduced deflection, less bending is compared to determinate beams, and higher safety. Even if one support fails, structure may still stand, and also it provides better stability. It is more resistant to vibration and external forces. Example, if a continuous beam in a building slab distribute load across columns, making it safer than a single span beam. To quantify indeterminacy, we use the degree of static indeterminacy. It is computed from the difference of total unknown reactions and the number of equilibrium equation. If dSA is equal to 0, it is said to be an indeterminate structure. If it is greater than 0, it is said to be an indeterminate structure. So beam with three unknowns and three equations. In this case, degree of static indeterminacy is 0. But in case of beam with 5 unknowns and 3 equations, the degree of static indeterminacy is supposed to be 2. That is, the structure is said to be indeterminate. This means we need two additional equations from deformation compatibility. So the degree of static indeterminacy tells us how complex the structure is and how many extra conditions are needed to solve the problem. The applications of statically indeterminate beams are they are used everywhere in civil engineering. Some important applications include multi-story buildings where continuous beam connect multiple columns, and bridge decks where loads are distributed across supports, and industrial structures where heavy loads require strong support system, and also in continuous slabs and girders, which is used in reinforced cement concrete design. Why they are used? Because they improve load sharing, reduce material usage, and enhances durability. So this concept is not only just theoretical, it is also used almost in every real life structure. Let's quickly summarize what we have learned today. We have learned about indeterminate beams, which have more unknowns than equations, and the equilibrium alone is not sufficient. Compatibility of deformation is also essential. Degree of static indeterminacy helps in measuring complexity of the structures. These beams are widely used in practical application. In simple words, indeterminate beams are more realistic and safer than determinate beams. Now let's think deeper. Why indeterminate beams are structures preferred in real life engineering? The hint is think about safety, think about load sharing, and think about future conditions. Take a moment, pause the video, and discuss with your friends for the answers. And also, let's test our understanding with two simple questions. First question is a beam is statically indeterminate when it is when unknown reactions exceed equilibrium equations. Additional questions equations are obtained from compatibility of deformation. For further understanding, refer to the following standard textbook, online resources, and lecture videos. This topic forms the base for advanced methods like slope deflection method, moment distribution method. Thank you for watching this video. If you found this useful, like, share, and subscribe. See you in the next lecture. Have a good day.